Hello, my name is Jacob, and I will be presenting the case study on the Tug Fork River. Firstly, a little bit about the Tug Fork River. The Tug Fork River lies upon the southwestern border of West Virginia and part of the western border of Kentucky. The watershed covers about 1,500 square miles. The Tug Fork River has an average flow rate of around 1,500 cubic feet per second. The entirety of the Tug stretches 159 miles from its headwaters in the south to its confluence with Louisa Fork, right here, where it becomes the Big Sandy River, which soon flows into the Ohio River. The Tug supports a healthy population of smallmouth bass, which do well in its cool waters. The Tug Fork watershed is shared between the states of West Virginia, Kentucky, and Virginia. The watershed is mainly forested land with several small towns totaling a population of about 276,000 residents based on the 1999 population estimates. The watershed covers 8 counties from 3 states. It includes McDowell, Mingo, and Wayne counties of West Virginia, Lawrence, Martin, and Pike counties of Kentucky, Buchanan and Tazewell counties of Virginia. The primary land use within this watershed is coal mining, including both surface mines and underground mines. The second land use within the watershed is for timber. The area has very limited agriculture due to its topography. Since the recent boom in kayaking among West Virginians and other outdoorsmen, the Tug has experienced more and more kayaking traffic. The Tug Fork River falls under 2 designated uses for West Virginia. It is the primary supply of drinking water for several small towns located along its banks, delegating the stream as Category A, public drinking water supply. The associated water quality criteria for this category in this stream are fecal coliform, iron, and manganese. All waters in West Virginia are classified as Category C and must meet the quality criteria for contact recreation. In this case, fecal coliform, biological conditions not allowable, and selenium. Tug Fork is on the 303D list, which is the list of impaired streams which do not meet water quality criteria that is submitted to the EPA by all states. It has been on the impaired list since the turn of the 2000s. The major problems impairing Tug Fork are metals including aluminum, manganese, and iron, along with pH. The sources for these contaminants are both point and non-point. The point source pollutants are mainly from permitted discharges stemming from mining activity. Acid mine drainage from abandoned or closed mines make up the majority of non-point pollutants. The remaining non-point pollutants include lumbering sites and roadways. The specific pollutants causing impairment of Tug Fork are biological conditions not allowable from river mile 27.5 to the headwaters, fecal coliform due to untreated sewage reaching the river from non-point pollutants for the entire length, and too high of concentration of selenium due to acid mine drainage affecting the river from mile 143.2 to 157.1. The data that was collected and used for the TMDL was acquired through the required upstream and downstream monitoring of permitted discharges that the holding mining companies must conduct. The WVDEP requires mining companies to submit this data across the state. Not only was the data from the mining companies utilized, but also data from the EPA STORET database, the WVDEP DWR, and also the Kentucky DEP DEW. As you can see here, the non-point sources far outweigh the point sources here in pounds per year in all 3, including aluminum, iron, and manganese. Some cases, this is over 10 to 1 in how much the non-point sources outweigh the point sources. This can also be seen in resonance along the load allocations for both the non-point and the point sources here. The models used to calculate the TMDLs for this stream are based upon the numeric water quality criteria for aluminum, iron, and manganese, along with pH in West Virginia. These would also be used to set endpoints for the TMDLs, which included an explicit margin of safety. The margin of safety is set at 5%. The three pollutants of total iron, aluminum, and manganese were further modeled using the HSPC, including algorithms from the iWater and the pWater. As you can see here on the right side of this chart, the human health concern for iron was set at 1.5. This would be in milligrams per liter. The manganese was also set in milligrams per liter at 1.0. There was no human health concern for aluminum. Only in trout waters would aluminum be considered. This would be at 750 micrograms per liter, but we do not have to worry about that, as this is a cool water fishery and not a cold water fishery, and therefore cannot sustain trout life. The pH value is also considered to be within 6.0 to 9.0, and this is the same all the way across the state, as you can see here, no matter what kind of water it is. Even though West Virginia did not require an aluminum limit, this is a shared stream between West Virginia and Kentucky, and based on Kentucky law, the aluminum endpoint had to be set at 712.5 micrograms per liter. The other endpoints were as follows: iron at 0.95 milligrams per liter, minus a 5% margin of safety. The manganese endpoint was set at 0.95 milligrams per liter. Wait, you might be wondering about the endpoint for pH. Well, it turns out that pH can be a misleading indicator, so it was proposed that by reducing the metal content, especially iron and aluminum, the pH would return to a neutral level based on the Mintekwa 2 and the MEET water quality standards, so an endpoint would not need to be set. The health of the Tugfork River can be approximated quickly using whiskey scores. The WVSCI score is the West Virginia Stream Condition Index that is generated using a kick netting technique that produces quick and helpful data when it comes to partitioning of valuable resources to stream management. Here on the left is an example of kick netting, where a fine mesh net is placed in the riffle of a stream, and then the substrate is then disturbed upstream of the net. The current will then bring macroinvertebrates downstream into the net to be caught. This is done in 1 cubic yard to sometimes 2 cubic yards. As you can see on the right here, the whiskey score percentages for the tug, they rank impaired much higher than the state average. You can see 35% compared to 22%, a fair margin. The middle gray zone here represents scores that could go either way. On the left here is a random data set of the percent stream miles in various fecal coliform bacteria categories. This would be the Tug Fork versus a statewide average. As you can see, below 400 colonies per 100 milliliters of water, the Tug Fork ranks lower. This is actually worse because this is the end that you want to be on. As you get farther towards the higher counts, you can see that there's a greater margin here that the Tug Fork stays much higher than the state average. The graph on the right here, you can see stream miles with poor aesthetic trash visual rating for the watersheds in the state. As you can see, the Tug Fork ranks extremely high. In fact, the highest of all our watersheds, the closest being the Coal River. The Tug Fork River includes 28 NPDES permits. These are mostly general sewage permits. That includes most of the schools and churches along the river. There are also some stormwater construction general permits, including industrial. Here you can see a table of the NPDES permits. The table includes the contaminant sources, the types of the contaminants from those sources, and the monitoring requirements by the state of the individuals that hold the permits. On top here, you can see a stormwater construction general permit. That generally includes contaminant sources of vehicles and storage tanks. The types of contaminants that range from this can be sediment, iron, aluminum, and fuels. The state requires weekly inspections of equipment and discharge grabs within 30 minutes of a rain event. There is also a general sewage permit. This includes contaminant sources as gray water and raw sewage. The main contaminant is fecal coliform. This also requires monthly sample grabs. There's also a general stormwater industrial permit, which includes fuel storage tanks and uncovered equipment. The contaminants range from chemicals to heavy metals. This is similar to the stormwater construction and requires weekly inspections of equipment for leakage and barriers for containers. I would like to thank these resources for the graphics and information presented. Thank you.